I'm Vlad. You may have seen me before. Partner in crime at Strong Bytes, one of the organizers of this beautiful conference along with Code Camp. And this is the obligatory headshot. This is the summer edition of me. This is the, oh my God, I can't believe it's summer already edition of me. Yeah. And today we'll be talking about how to read minds. Yeah, in order to get your attention. But basically, we'll be talking about building recommender systems and how they work, all in half an hour. And I'll start this off by asking a very important question. Are you ready? That's not the question. Okay, what superpower would you like? If you were to have only one superpower, which would that be? And don't take into account the title of this presentation, please. And who said mind reading? Okay, but something more exciting. Invisibility, good one. Electricity, teleporting. Yeah. I know, right? There are a lot of cool powers apart from mind reading. My personal one would be to just skip through time, you know? So I'm a big fan of the butterfly effect theory, so I believe that seemingly small actions do have a big effect on the future, and I'd like to explore that. But a lot of people do believe that mind reading is nice. And usually I laugh when they said that, but have you heard about time skipping? But after a while, they started making sense. You know, because it's nice to be able to read the thoughts of the other person, of the other party you're interacting with, both in a personal environment, but also in a business-to-business environment. Yeah, because we're all here very busy business people. Very serious, highly, yeah, professional. Yeah, it's nice to be able to say, I know you want this, this, and that. Yeah, I know you want me to build this solution, even though the other party can't really express themselves, or maybe they can. Yeah, and the advantage with reading minds, with making things personal, is that offline this is easy. So for example, again, going with the business-to-business approach, if I go into my favorite coffee shop and I order, wait, I don't even get to order anything because the barista sees me and starts brewing me a, well, latte macchiato single shot ristretto, because that's what I drink most of the times. It's a very manly drink. And this is nice. It makes me feel seen. It makes me feel understood. It makes me feel like I matter. And I think we all want to matter. Yeah, we all want the other people to understand us. And again, this is approachable offline. Yeah, when you have 100 customers a day, you do manage to do this. But when you have 100,000 customers a day, it may not be so easy. Yeah, if you're Amazon and everybody starts asking, what should I buy? Hello, people from Amazon. I know you're here. It's getting hard. Yeah, it's not as easy. It doesn't scale as well. Well, of course, unless you build a system. This is why we're here. We're building systems. We make things easier. So what kind of a system would you build? Yeah, you would build a recommender system. And everybody does that. Yeah, you have ads that are getting recommended to you. You have books that are getting recommended to you. This is how you discover new movies. Yeah, they're being recommended. New songs, new friends. Yeah, ooh, add friend. Yeah, so it's everywhere. Yeah, and it's everywhere for a good reason. There is this is a very good approach, and there are a lot of profits to be made from recommending the right things to the right people. Yeah. And there is a lot of interest right now in building recommender systems. And I'd say the interest really started growing about 12 years ago when Netflix, does anybody here know Netflix? It's a lesser known company, perhaps. You may have you heard of it? No. Yeah, it doesn't even matter, you know? But they had a big machine learning contest 12 years ago that lasted for 3 short years. And they said something like, okay, this is our data set. This is a big data set of users, movies, and ratings. And it was anonymized, but people still could identify the users, unfortunately, some users. And basically what they asked for was, okay, anybody who manages to build an algorithm that improves our baseline estimations by 10%, and they were using the root mean squared error, which may not have been the best idea, but they did. Anyways, anybody who would improve those, their results by 10% would get $1 million. 3 short years afterwards, 2 teams improved their results by 10%, but only one got the prize because they were 20 minutes earlier. So yeah, that was fun. It was a great competition. It started this interest with machine learning competitions. Think about how Kaggle is doing now. And it also brought machine learning into the public eye. Yeah? But yeah, we're talking about recommending things. What is a recommender system? Well, basically, at its core, a recommender system is a system that takes users and items and makes recommendations, recommends to a user the items he or she is most likely to consume. And here, by user, we can have anything. So, for example, in the case of me interacting with Google search, I am the user, and their ads are the items that are recommended to me, based on my profile, based on my behavior. Whereas in the case of LinkedIn, I think I'm the item. I'm the item, and the companies and the recruiters, they're the users, and I'm being recommended to them. Yeah? So a user can be anything, an item can be anything, consumption can be anything. Yeah, you can consume something by watching it, by looking at it, by buying it. Doesn't matter. But basically, that's the gist of a recommender system. And we have 2 types. Are you ready for the first type? For one, we have content-based filtering. Basically, content-based filtering focuses on building profiles for users and on building profiles for items. And then on using those profiles in order to make recommendations. And this is why they call it content-based. Yeah? It's based on their content, on my behavior, on how I act, and on how the items act. Yeah, and then there's collaborative. I tend to pronounce collaborative like the not cool kind of Dexter. But yeah, I know it's collaborative, right? Collaborative. Collaborative. Collaborative sounds fine. So collaborative filtering, this doesn't take user profiles into account. Yeah, it takes the ratings. Yeah, it takes the interactions between users and items. And it takes them as a whole into account. So this is why we say it's collaborative filtering, because the users collaborate between themselves in order to provide the best recommendations. Yeah? Okay, I lied. There's also hybrid systems. Yeah, you know, hybrid systems in which you use both collaborative techniques and content-based techniques in order to yield the base results. Because as we will shortly see, there's no one-size-fits-all solution here. It all depends on the context, as Jan said. It all depends on what you want to achieve. Okay. This isn't the end of the talk. We're going to go a bit into more detail. Yeah, first, let's take content-based filtering. Yeah, we have some users and some songs. I like songs. Yeah, and for every user, we can start off by building a user profile, if we were to build a recommender system using content-based filtering. Yeah, and for the profile, I don't know, we might choose the gender, we might choose, I don't know, age, maybe even perform a short survey when they sign up, log in to our application and see their preferred genres. You know, so we can have some seed data there. And then for every song, we can also get a profile. Yeah, we need to understand the song. Maybe what's their artist, what's their year, the year of release for that song, what's the genre. Maybe even run some NLP on the lyrics and try to find out the song theme. Yeah, building a profile. And it would look maybe something like this. By the way, all these songs are from my playlist except one. I challenge you to find that. Nah, why? Yeah, it's Despacito. But I put it here because yeah, it was funny. Anyways, so we have several songs, and let's say 4 users: Alice, Bob, Carol, and Dave. And these are the ratings. And one small note: if the ratings aren't necessarily explicit. Yeah, it's not like every user just clicked a 5 for a song, or clicked a 1, or didn't click anything. Because a lot of users don't tend to rate items. Yeah, you need to infer those from their behavior. However, those are lesser people than the ones here. I'm sure you like to rate items and to give feedback at all conferences you attend. So you should probably visit ndrconf.ai/feedback and leave some ratings. Thank you. But again, we have some ratings here for most of the songs. For some, we don't have them. Obviously, they weren't listened because all the users give ratings. And some small profiles. I only chose to build item profiles and not user profiles because that was simply easier. For every song, we have a genre which can contain, let's say, more items in some cases, and the year of release. And what we want to build now is a system that can predict what ratings would, for example, Carol give to Shake It Off, and based on that rating, decide whether or not to recommend Taylor Swift to her or not. Yeah? This is what we're trying to build. Let's see how we would approach it in this case. Well, one approach would be without taking into account the ratings of the other users, because that's collaborative filtering. One approach would be to just try to create clusters from the user profiles, and try to deduce from those clusters, from how far apart 2 songs are, or from how close they are, try to deduce the ratings. We won't do that. Another approach is if we were to look at these rows, we could see this looks like a classic machine learning problem, right? This looks like a regression problem in which we have the ratings of the user as the labels and the profile as the features. So all we need to do is find, I don't know, a formula, a model trained on this profile that can yield a rating. So let's say, for example, we give it data training like for scar tissue, Carol hates scar tissue, doesn't like it. Yeah, so for alternative songs released in 2004, you have a rating of 0. For alternative songs released in 2003, you have a 2, and so on and so off. Yeah, and you can train a model based on this, and then for every user, and then apply that model for the rest of the users, and use it to get new predictions, and sort those items with the highest rated, with the highest rated, from the highest rated, by the highest rated. Pick the highest rated. Have you? All right, and make those recommendations. Yeah, of course. In our approach, we may need to perform something like one-hot encoding, because we don't want to be bothered by cases in which a song has several genres or not. But this is also another approach, an approach that does work in this regard. Yeah. Any questions so far? Void. Infinite void. Okay. The advantages of this solution is that, on the one hand, it doesn't depend on multiple users. Yeah, it's focused on just one user, so it's a bit simpler. Also, it does tend to recommend it gets to recommend unpopular items. Yeah, it serves the long tail, which we can't really say about collaborative filtering. Yeah, because all we take into account while making recommendations is the item or the user profiles. So this means that also, on the one hand, only the content matters, but cold start issues are less likely. Cold start issues are when a new item or when a new user enters our system. Yeah, and in that case, we don't have a lot of data about them. We don't have a lot of ratings about them. And it's hard to make recommendations based on those. But if we are to take the profile into account, this becomes easier. Yeah? However, this class of algorithms does tend to over-specialize a bit, does tend to recommend the same items over and over, or the same or very similar items over and over again. And for example, I like alternative music, but if I listen to it 2 days in a row, I get cranky. You know, you do want some variety. There's also the issue with the difficulty of understanding items, yeah, or users for that matter. Yeah, because especially in the case of rich media, yeah, if you need to understand a movie, what's in that movie, what's its content, it's not as straightforward. And in this case, maybe collaborative filtering works better. Yeah? And then, of course, there's collaborative filtering. I'm going to pronounce it in 1,000 different ways, don't worry. Same idea. You have relationships between users and items. Only this time, we don't take the profiles into account. This time, we take the ratings, yeah, and only the ratings. And we take them as a whole. And here, we have several approaches. Yeah, we have user to user, in which, in order to predict the rating a user would give to an item, we look at the ratings all the other users have given to that same item. Item to item, which looks at the ratings all the other items got from the same users. And matrix factorization, which is basically, yeah, we're trying to build a low-rank matrix from which to be able to calculate the ratings. We won't touch that. OK, same table, yeah, same actors, same songs. Again, we have their ratings, but let's say we want to predict Dave's rating for scar tissue. A naive approach would be just to look at how the other users have rated scar tissue and average it out. This would give us, I think, yeah, it's 233. 5 plus 2 plus 0 over 3. Is this a good approach? No, why? Huh? He doesn't what? Yeah, maybe he doesn't care about their recommendations, right? Sorry, could you repeat that? The data set, of course, it's really small, but Sergio there had a good point. If I am to listen to music recommendations, I do tend to take into account the people I feel like I have something in common with, the people like that listen similar songs to what I like. And in this case, yeah, Alice, Bob, and Carol might not be great recommenders. If we are to look at the ratings between Dave and Alice, for example, we see that they don't have a lot of overlap, yeah? Dave likes Lordi, Alice not so much. Dave likes Major Lazer, Alice so and so. Same with the White Stripes. So maybe they don't have that much in common. With Bob, it's even worse, I think. With Carol, he has some preferences in common with Carol, so it would make sense that her recommendation would influence him more. Yeah? And how do we do that? Well, instead of calculating a simple average, we calculate a weighted average using the distance between them, using a similarity metric, such as maybe the Pearson coefficient or cosine similarity or some other metric. I have not included any formulas. You're welcome. Yeah, we can use those, and basically what they do is look at the ratings of the other user compared to the ratings of Dave for the items that both have rated, and see how far apart they are. Yeah? Okay. An advantage of this approach is that it doesn't need to understand the data. Yeah, it doesn't care. Just looks at the ratings, just looks how the other users behaved, and makes recommendations based on that. So, big advantage. However, in the case of items that haven't already been rated, or in the case of users that haven't rated anything, this is an issue. Yeah, because they can't do anything. And what do we do here? I don't know, maybe just recommend the generic popular items. Or maybe take a look at hybrid systems, to which we'll get to in a moment. Yeah, also, it does tend to recommend popular items, because it looks at the ratings, it sees that a lot of people have rated an item highly, so yeah, you should totally consume this, right? And then there's hybrid systems. And hybrid systems are interesting. Hybrid systems basically try to alleviate the issues with both collaborative filtering and content-based filtering. And here, it actually depends what you want to achieve. Maybe you will build two models, one collaborative, one content-based, and ask them to rate to provide a number of n items, and then just merge the two data sets. Or maybe, if you take a look at the context of the user, you will build a content-based system and a collaborative system, but just use the content system until you get enough ratings from a new user, and then start using his or her ratings in order to make recommendations. Yeah, so at the beginning, use a higher weight for the content-based model, and then switch the weights. Yeah. And there's also a couple of things to look out for while building a recommendation system. Yeah, as I mentioned, we have cold start issues. If I go and sign into Apple Music and ask them to provide a playlist with music I like, they don't know anything about me. They just know my email. But if I am to fill in a survey first, filling out my I don't know, preferred genres, or which artists I like, then they already have some information about me. They have a profile. So they can use content-based filtering at first to make recommendations. And then once I've started using the system, once I've started rating items, they can increase the importance of their collaborative filtering algorithm. Yeah? Also, context matters. Again, as Ian said, if I am to ask Netflix for a movie to watch for Christmas, and it gives me the Saw 3, I will not enjoy Netflix. Yeah, same as for Halloween. If it gives me Saw 3, I will not enjoy Netflix. I haven't watched Saw 3. I think it's scary. Anyway, so context matters. If you get the chance to find more about your user, you will be able to not recommend workout music while they're trying to go to sleep. Yeah, or not recommend sleepy tunes while they're doing their workout. Yeah. Also, again, using the song example, I generally prefer to listen music related to the music I've recently listened to, as opposed to items related to the music I've listened to 15 years ago, because tastes change. Yeah. So, and the same with shopping. Yeah. Maybe I don't want to get recommended, I don't know, that kid's bicycle I bought 30 years ago. Maybe I want to be recommended a cool adult bicycle, and something like that. So recent items would always, or most always, depends on the context of course, take precedence. And there's also the issue of explicit and implicit feedback. As I mentioned, apart from IT conference attendees, people don't tend to give ratings so much. But they do tend to interact with items. So instead of basing our scores on explicit feedback, like a score, a like, or something like that, we should take into account also how they interact with items. Have they listened to the whole song? Or have they pressed skip after the first 5 seconds? How many times did they listen to a song in the past week? Is it once or 100 times? And all these metrics need to be transformed into a number, into another metric, with using an algorithm, that suits your business, that suits your use case. But you can't always, or most times, you can't base your systems on explicit feedback. Thank you. I've been Vlad.